Hello, class. This is the second video covering activity 3.7. In the last video, we had finished up problems 1 through 8, and we're going to begin this video by starting with practice problems 9 through 13. So if you remember questions 4 through 8, we were given an equation or a function that was in exponential form, right? Here's my exponents. And we were asked to rewrite them in logarithmic form. Now we're going to do the opposite. Questions 9 through 13, we're going to start in logarithmic form, and we're going to end up in exponential form. Okay, so here, the base of my log is 2, so the base of my exponent will be 2. Remember, the exponent's what we tried to free, so that's the 3. So now I add my 3 as the exponent, and the 8 is on the other side. And then just ask yourself, is 2 raised to the 3, does it equal 8? And the answer is yes. So we know we've done this correctly, right? Because 2 times 2 times 2 times 2 does indeed equal 8. The mistake I see sometimes would be someone would write 3 squared equals 8. And we know this doesn't work because, well, 3 times 3 does not equal 8, right? So we'll cross that out. All right, so the answer would be 2 cubed equals 8. Right, so if I give you logarithmic form and I say end up in exponential form, this is how we would look. Okay, let's take a look at number 10. All right, so the base of my log is 3, so the base of my exponent is going to be 3. The 2 comes up top, and the 9 goes on the other side. And then just ask yourself, is 3 squared, does that equal 9? The answer is yes, so we know this worked out. All right, when I look at number 11, my base is 5, right? The base of my log is 5. The exponent's that negative 2. And the 1 over 25 goes to the outside. And that works, right? Because 5 raised to the negative 2 is indeed 1 over 25, right? So just remember, right? 5 squared equals 25. So 5 to the negative 2 is 1 over 25. Oops, my stylus went a little crazy. Right, so this answer is indeed correct. Let's take a look at number 12. All right, base of my exponent is 3. The 1 is my exponent, and the 3 goes on the other side. And then just ask yourself, is 3 raised to the 1 equal to 3? And the answer is yes, it is. Last one, the base of my log is 4, so the base of my exponent is 4. The exponent is 4, and we get 256. Okay, so we've taken something that was in logarithmic form, and we wrote in exponential form. Okay? Next, we have to talk about 2 special bases. All right, we have this base 10, which is called the common log, and base e, which is called the natural log. So you might wonder, why do we have these special bases? Well, your calculator is actually already in base 10 and base e. If you look at your calculator and you look at this LOG button, that's in log base 10. And if you look at the ln key, the natural log, well, that's actually in base e. All right, so here you see the ln is base e, log is base 10. You see, all of the problems we worked with before, see here, this is base 2, problem 10 is in base 3, problem 11 is in base 5, and so on, right? Problem 13 in base 4. Our calculator's in base 10, so we can't just simply enter log 256 and get an answer, because our calculator has to be in base 4. Now, some of the newer calculators, you can actually change the base to base 3 and base 4. But for the purposes of this course, right now, we're going to leave our calculator in base 10 and base E. So if you look at problem 14, it says rewrite in logarithmic form. So if you look, the base of our exponent is in 10. So I can write log. Here's my base of 10. And the exponent's what we're trying to get by itself, which is the 2, and the 100 comes inside. Okay, now you can leave it like this, But you really don't need to show me the base 10. If I simply write log 100, it's understood that we're in base 10, right? So these two things are really the same, right? So you could write log base 10 of 100 equals 2, or if you just simply write log 100, we know that you're talking about log base 10, okay? And if you wanted to check your answer with your calculator, let's pull up my trusty calculator. If I type in log 100, close my parentheses and press enter, well, I get 2, right? So the log of 100 is indeed 2, and we verified that with my calculator, right? Let's take a look at number 15. So in 15, the base of my log is 10, so I can write log base 10. The 0.001 comes inside, and the negative 3 is on the outside. All right, so again, this answer is acceptable, but you could simply write log 0.001 equals negative 3, right? You don't have to actually write the log base 10. It's understood we're in base 10. Okay, if I look at number 16, the base of my log is 10, so I can write log base 10. The 1 comes inside, and the 0 goes on the outside. So really what we're saying is log base 10 of 1 is 0. This is actually an important property to know. Okay, log base 10 of 1 equals 0. This is almost one that you might want to memorize. If you look at number 17, okay, anytime you see the letter E, you should use the natural log. So ln base E of 1 equals 0. And anytime you use ln, it's understood we're in base E. So you don't actually have to write the E. Right? And if I want to verify this with my calculator, I press the ln key. I press number 1, and then I press enter, right? So the natural log base E of 1 is 0. If I did log base 10 of 1, that's also 0, okay? And we verified that through problem 16 and 17, all right? And then I guess the last one is number 18. The natural log I'm going to use because I see the letter E. Anytime I see E, I use ln or the natural log. So we know it's in base E. I don't really have to write this. And then I'm going to put the 1 over E cubed. And let's see if I can write that a little bit better. Not much better, but we have natural log base E of 1 over E cubed equals negative 3. Okay. And again, you can simply just write natural log of 1 over E cubed equals negative 3. Okay. Okay, number 19. All right, so here, 16, 17, 18, we were in exponential form and we ended up in logarithmic form. Here are my logs. Now, 19, 20, 21, we start out in logarithmic form and we're going to end up in exponential form. So I'll do that in the third video.